So in this video we're going to discuss monatomic ions. We're getting ready to look at chemical bonding, and ions are an important part of that. Things to remember. The identity of an atom is determined by how many protons it has in its nucleus. If you change the number of protons, you change the atom into something else. The other thing you want to remember is that when we use the word neutral, in a neutral atom the number of protons and electrons are the same. And that's because neutral means the number of positive charges is equal to the number of negative charges. We're going to be dealing now with particles that are not neutral anymore. They have a charge. So an ion is a charged particle. It could be a molecule with a charge or just a single atom with a charge. Monatomic means one atom. So we're going to be looking first at atoms that have a charge. If it has a charge, it means it's not neutral. And if it's not neutral, that means that the number of positive charges is not equal to the number of negative charges. So how does that happen? How does it happen that you might not have equal numbers of those? Well, there's two things that can happen to an atom that will give it a charge. Either the atom can gain electrons, or it can lose electrons. That's it. We cannot mess with the number of protons, because if we mess with the number of protons, we change the atom into something else, another atom, another element. So the only two ways to get the number of protons and electrons to not be equal is either gaining or losing electrons. Those are the only two ways to form an ion. So we have two types of ions then. Ions with positive charges or with negative charges. Positive charges happens when an atom loses electrons. Now this is where things are going to be a little tricky until you get it into your head. In math, you know the word lose means minus, and yet here when you lose electrons it actually gives you a plus charge, a positive charge. Well, think about why that is. If you lose electrons from an atom, now it has more protons than it does electrons, and since it has more protons and protons are positive charges, there are more positive charges in the atom than there are negative charges, and that gives it a positively charged charge. Okay? We call this a cation. Now, it's not called cation. It's called cation. So remember how to pronounce that, because it's very important. Nothing says that you don't know what you're talking about more than when you mispronounce a word like cation. Okay? Cation, the prefix cat means positive in chemistry. Metals are the elements that do this. Metals like to lose electrons. We say metals are losers. Okay? When a metal loses an electron, it becomes positively charged, one or more electrons. It becomes a cation, and its name is just the name of the metal plus usually the word ion at the end. Okay? The other possibility is to form a negatively charged ion. Negative ions happen when an atom gains electrons. Here again, gain in math, usually gain is plus, but here gain means negative. Why is that? Well, because if you're gaining electrons, you'll have more electrons than you have protons. And if that's the case, there's more negative charges in your atom, and that gives you a negative charge. These ions are called anions, not anion, and certainly not onion. Anion. An, the prefix an in chemistry, means negative. Okay? Nonmetals are usually the ones that do that. So metals are losers. They lose electrons. They become positive. Nonmetals gain electrons and become negatively charged ions. Now, when a nonmetal gains electrons and becomes negatively charged, its name changes. The ending of the name of the ion changes to IDE, "ide." Here's a couple of examples. So Na is a symbol for sodium. It has a plus charge written there, so that's a sodium ion. We call it the sodium ion. Cl with a minus charge is from chlorine, but because it has a minus charge, it's an anion. We call it the chloride ion. Okay? So, how do we know what charges an atom will have? How do we figure out? Is it going to gain? Is it going to, well, we know if it's a metal it'll lose, if it's a nonmetal it'll gain, but how do we know how many electrons it will lose or gain? It's all about the valence electrons, and this is why we had to learn about valence electrons first. See, the thing is, all of the main group elements, the representative elements, not the transition metals, the representative elements, the main groups, all of them are trying to get 8 valence electrons. Now, which elements on the periodic table have 8 valence electrons already? If you said the noble gases, you're right. The noble gases have 8 valence electrons already. Every other element on the periodic table in the main group wants to be like a noble gas. Because when you have 8 valence electrons, you become stable. And stable means low in energy. And nature loves to get things lower in energy. So if you can stabilize an atom, you will lower its energy and it'll become happier. Okay? So noble gases are stable. They're stable because they have 8 valence electrons. What does that mean? Well, a noble gas is already stable. That means it doesn't do anything. It won't react generally with other elements. It's happy as it is. All the other atoms on the periodic table, they're not happy yet. And so they're going to either gain or lose electrons to become like the noble gases and become stable. The word that we use for this, very complex word that we use to show that means to have the same number of electrons as something else, the word is isoelectronic. Iso means same, electronic means electrons, same number of electrons. So all of the elements on the periodic table try to be isoelectronic to a noble gas. This whole process is called the Lewis octet rule. You remember Lewis? He's the guy that came up with the dot structures. He worked with electrons. Well, Lewis also came up with this rule that all atoms try to have 8, octet, 8 valence electrons. So that's the Lewis octet rule. And all atoms will try to do this. There are some exceptions. The two most important exceptions to this rule are hydrogen and helium. Helium is already stable. It's a noble gas, and it only has 2 electrons. Hydrogen, in order to become like a noble gas, just has to gain 1 electron to be like helium, and it will be stable. So those are the two biggest examples of an exception to this rule, where they don't need 8 valence electrons, they only need 2. Okay? So, we now know why this happens. Now we have to figure out how we're going to know the charges. Okay? So, an atom will take its easiest path to get 8 valence electrons, whatever takes the least amount of work or energy. Okay? Metals, since they like to lose electrons, the reason they like to lose electrons is because they're way over on the left of the periodic table. And it's easier for them to lose 1 or 2 or 3 electrons to get backwards, go backwards to be like the previous noble gas, which has 8. So they'll be positive. Nonmetals are closer to the noble gases on the right, and so they have to gain a couple of electrons, 1, 2, or 3 electrons, and they'll become like their next noble gas. They'll become isoelectronic to that one. You don't generally find elements that will gain or lose 4 electrons in the main group because it costs a lot of energy to do that. And since it costs about the same amount of energy to gain 4 as to lose 4, instead of deciding, they find a different way of becoming stable. We'll talk about that later. Okay? Now, when we write an ionic symbol, we're going to write the symbol of the element, and then we're going to write the charge, plus or minus, as a superscript to the upper right. If you lose or gain more than 1 electron, then you're going to use a whole number, 1 or 2 or 3, or 2 or 3 usually, to represent the number of charges that you have. Okay? For example, nitrogen, when it forms an ion, nitrogen will gain 3 electrons to become isoelectronic to neon. Neon has 10, nitrogen only has 7. So if it gets 3 more, it becomes like neon. And because it's gained 3, it's going to have a -3 charge. And so we write N with a -3. The name of nitrogen is no longer nitrogen because it's negative. It becomes nitride, IDE. Magnesium has 12 electrons. It's easier for magnesium to just lose 2 electrons to become isoelectronic to neon as well with 10. And then we write it +2 or 2+, and so on. Okay? So looking at the periodic table, we can figure out how many electrons an atom will gain or lose to form or to be like its nearest noble gas. So we can look at the periodic table, pick any main group element. Let's take selenium, for example, number 34. Well, selenium has 34 electrons when it's neutral. If it wants to become stable like its nearest noble gas, the nearest noble gas to selenium is number 36, krypton. So selenium just has to gain 2 electrons to be like krypton. When it gains 2 electrons, it becomes a -2 charge, and its name becomes selenide instead of selenium. Okay? So that's how we can figure out how many electrons an atom is going to gain or lose and what its charge is going to be. So we'll try some. Here's a few that I want you to try. Figure out the symbol with the charge and the name of the ions that are formed by potassium, oxygen, aluminum, and sulfur. Stop the video, take out your periodic table, and figure those out and see how you did, okay? I'll wait. All set? All right, well, let's see how you did. Did you get K with a +1 charge for the potassium ion? Potassium's a metal. It's going to lose 1 electron to become isoelectronic to argon, and that will give it a +1 charge, and we call it potassium because it's positive. It doesn't change its name. What about oxygen? Well, oxygen has 8 electrons, very close to neon with 10. If it gains 2 more, it becomes like neon, but then it also has a -2 charge. And it's a negatively charged ion, so its name has to change. Now, oxygen and sulfur are 2 examples of ones that the changing of their name is a little funny. Oxygen doesn't become oxygenide, it becomes oxide. But you've probably heard that word. Aluminum. Aluminum has 13 electrons. It's easiest for aluminum, which is a metal, to lose 3, to be like neon. And if it loses 3 electrons, it will be +3, and it will just be called the aluminum ion. And finally, sulfur. Sulfur is in the same family as oxygen. And because it's in the same family as oxygen, it does exactly the same thing as oxygen. So sulfur gains 2 electrons to be like argon, and it becomes a -2 charged ion, and we call it sulfide. Not sulfuride, sulfide. Okay? All right, so far we've been ignoring the transition metals. And we've been doing that because the transition metals, well, they don't follow the rules. They're like those motorcycle leather jacket wearing tough guys that push freshmen into lockers in the high school. They cause a lot of trouble because they don't follow the rules. As a matter of fact, the transition metals, there are a lot of them that have more than one possible positive charge. How the heck is that happening? Well, with transition metals, it always comes back to the d electrons. Because they have their highest energy electrons among them are in the d sublevel. That causes all sorts of problems. And the transition metals have different ways of doing things. So the first thing you have to understand about the transition metals, they're metals, which means they're going to be positively charged ions. But figuring out how many electrons they're going to gain or lose, you can't do it just by looking at where they are on the periodic table. That's really important. There is a way to do it. You can look at your periodic table. And if you look at your periodic table, in the square, on the right-hand side, almost down at the bottom, there are a couple of whole numbers, integers, separated by commas. Those numbers represent the possible positive charges for those metals. Okay? Sometimes there's one in bold. Look at copper here. Copper has 2 and 1. And the 2 is in bold print. That means that copper with a +2 charge is more common than the other one, than the copper with a +1 charge. Okay? So you can look at your periodic table and you can find this information, figure out what are the different possible positive charges that the transition metals can have. Okay? So you can look at them at the periodic table. Which one it forms is depending on what it forms a compound with. A couple of things about the transition metal ions. If we have a metal, a transition metal that has more than one positive charge, for example, iron. Iron can be +2 and +3. Now, we can't call them both iron, because if I just call them iron, I won't know which one I'm talking about. Remember, metal ions don't change their names, so just calling them iron isn't good enough. We have to include some information in the name about the positive charge on that metal, and the way we do that is with a Roman numeral in parentheses after the name. So the iron with the +2 charge is called iron 2. The 2 Roman numeral means that it has a +2 charge. And the iron with a +3 charge then is called iron 3. Okay? That's how we do it. So when you are talking about a compound or an ion and you hear things like iron 3, you'll know, oh, it's an iron atom with a +3 charge. You don't have to worry about counting any spaces or anything. Okay? We only do that with transition metals, and specifically we only do it with ones that have more than one possible charge. It used to be done a little differently, and sometimes you'll still see these words around, so you should probably know them. In previous times, instead of using the Roman numeral, they did change the name of the ions, the transition metal ions. the one with the higher charge had an IC, an IC ending, and the one with the lower charge had an OUS or US ending. And they would also use the Latin root name of the metal instead of the actual modern name. So for example, iron's old name was ferrum. Iron has two possible positive charges, +2 and +3. The old name for those, the higher charge, the lower charge rather, for iron +2 would be called the ferrous ion, and the higher charge would be called the ferric ion. That's how we used to tell the difference. Nowadays we just say iron 2 and iron 3. It's a lot easier that way. It takes less thought. But you may see ferrous or ferric. So right now you want to get very comfortable with figuring out what the charge is on a main group element, especially main group elements. We do those more than the others. And looking at the transition metals, figuring out what positive charges, which ones have multiple positive charges, and what they might be called. Practice a little bit. Take your periodic table out. Give it a shot.